Let's look at section 2.5, transformations of functions, and you'll see the learning objectives there. We're basically going to work with recognizing basic shapes and moving them in different directions, up, down, left, or right, maybe doing some reflections and some stretches and some shrinks. We will want to pull out the graphing calculator, and if you check on WebCT, I've put a graphing calculator note sheet as well as some graphing calculator exercises for you to get used to working with the calculator. Just some basic steps on how to get started and how to get your calculator set. And I'll actually pull the calculator up here as we go through it. But let's look at the basic shapes we need to have memorized. Basically, burn these figures into your mind. Anytime you see any of these equations, we want to know automatically what the shape is going to be. Then we'll do some transformations. So the f of x equal x squared. We see that equation, we should automatically know that that's going to graph out as a parabola, and that the domain for this would be negative infinity, positive infinity, and the range would be 0 to infinity. Because of that center point there, 0, 0, the range would be 0 to infinity, but these arrows tell me domain will be negative to positive infinity. Absolute value. We need to know when we see that function that the graph of it, its shape is this V shape. Centered here at the origin, 0, 0. Notice the arrows tell me my domain will be negative infinity, positive infinity. My range will start at 0, just like the parabola, 0 to infinity. Square root is this arc shape. Starts here at 0, 0 and arcs out to the right. The domain, instead of negative infinity, positive infinity, because it starts here at 0, 0 and arcs out to the right, the domain is 0 to infinity. The range starts here at 0 and goes up to positive infinity as well. Okay, let's look at the other three shapes. X cubed is sort of this increasing S shape, starts down here in quadrant 3 and goes up to quadrant 1. Centered again at 0, 0. This one is an odd function. It's doing the same thing on both sides of the origin. Domain, because of those arrows, negative infinity, positive infinity. Range, negative infinity, positive infinity. Remember, always use parentheses with those, although that looks like a bracket, should be a parenthesis. The cube root of x is basically the x cubed shape, but laying down on its side. So the cube root of x would look like this. It's an odd function, centered at 0, 0. Domain, negative infinity, positive infinity. Range, negative infinity, positive infinity. And finally, the equation of a line, just f of x equal x, your basic line at the origin. Going again through 0, 0. Domain range, negative infinity, positive infinity, negative infinity, positive infinity. So we want to make sure that we have these shapes, these snapshots burned in our mind, so if we see any of these equations, we'll know what the picture is going to be. Let's do some investigations on our transformations. I'll pull these up on the calculator. And this is kind of hard to see, but that should be an absolute value of x. That should be an absolute value of x. I didn't do that very well. Let's see if I can do that a little bit better. I can't say that that's any better, but you'll see on your note sheet what it looks like. So I'm going to pull up the calculator and do some graphing, and we'll state any patterns that we notice. So let's do absolute value of x minus 2, x plus 4. Let's actually put in those first two together. So when you pull out your calculator, you have to turn it on, and there's your on button. To input an equation, we go to this y equals, and it's ready for us to put an equation in. The one I wanted to put in was absolute value of x minus 2. Well, the absolute value is tricky to find, but once you find it, these notes are on the note sheet, you'll be able to find it often. But we'll go to math, and we'll go over to NUM, and it is the first feature there, ABS. That's where we'll find our absolute value. So it puts it under my y equals spot, And the place we'll get our x value is always right here. We press that button to get our x. Since I want the absolute value of x, I'm going to close the parenthesis because if you notice the minus 2 is behind it. Make sure you close that parenthesis off. Once you have your equation typed out in your y equals spot, I suggest going to zoom and 6. Or you could just type in the number 6. Oops, it's going a little bit too fast, or too slow actually. Go to zoom 6 and enter there because it's going to put your window in a nice 10 by 10 rectangular coordinate system where we'll use as our standard viewing window. So we see the absolute values of V shape, but if I notice this one has been shifted down 2 units. So the relationship I see here is I know the absolute value of x is a V shape. That minus 2 causes it to shift down 2 units. Looking back at the graph. So it's the V shape down 2 units. Let's go to y equals, and I can go down below and type in the next equation, absolute value of x plus 4. So let's go to, we're at y equals, so let's find the absolute value, and I go to math and arrow over to number. In this case, I'll type in my x from the xt theta button, close the parenthesis, and in this case we'll put plus 4. Hit the graphing feature and it'll actually graph both of them. So notice the minus 2 went down 2. How does that compare to this one? Well, this one from the origin went up 4 units. So what could we say here? This one shifts down 4 units. Okay, let's pull up the calculator again and let's type in, go ahead and clear those 2 guys out, and let's type in absolute value of x minus 3. So under y equals, let's go find absolute value. Let's type in x, but I don't close my parenthesis yet because it's x minus 3. That's inside the absolute value. Now let's go ahead, hit the graph feature, and notice it's the V shape, but where has this one shifted? Notice right here is that point like our origin, and if I look at my spaces, it shifted 1, 2, 3 units to the right. And the equation is absolute value of x minus 3, so we see a different shift here. This one will shift to the right 3 units. When your number is outside the parentheses, it's up or down. Based on that sign, it goes with the sign. But when it's inside the parentheses, it's left or right and opposite of what you would think with a sign. Okay, let's graph this guy. So let's go back to y equals, clear that out, and let's type in a minus first. The place you get that minus is right here. We do not use a subtraction, we use the minus. Let's go back and get ABS. So we'll hit math, go over to NUM, hit ABS, and let's type in the x plus 1. So x plus 1. We have everything. We have the minus, we have ABS, x plus 1 in parentheses. So we're good. So let's graph it. Now let's check out the graph here. Well, looks like it's no longer at the origin. It looks like it's been shifted to the left 1 unit, but it's no longer opening up. The V shape is opening down. What do you suspect caused the V shape to open down? Negative in front. So the negative in front causes it to open down. The plus 1 causes it to shift to the left 1, which is again opposite of what we would think. So this will shift left 1 unit, and we see a reflection across the x-axis. Let's do these other ones real quick. The next one was, what was it? Go on. Let's see, it was minus the square root of x. So let's put that in. Let's go to y equals, clear that out, And let's type in the minus from down here. Let's pull in the square root, which is a blue button on top of x squared, and to get to anything blue we hit second. And let's get our x from our xt theta and close off that parenthesis. Well, let's graph it now. Normally, the square root looks like this. It's up here at the top. But here, the minus in front causes it to reflect across the x-axis, and that's what I had, right? Yep. So that negative in front causes it to reflect across, again, the x-axis. So let's write that out. Reflect across the x-axis. Let's graph this next one, square root of negative x. Y equal, let me delete that and put the negative. I can insert a negative there. Square root of negative x. And let's graph it. And notice what happened. The normal square root of x goes from the center point origin here to the right. The normal one arcs out to the right, but when you put a negative inside, it arcs out to the left. So there's a reflection. Let me go ahead and type in the square root of x just so you can see that relationship. Okay, that's what square root of x normally looks like. When you put a negative inside, it arcs out to the left. So a negative inside your function causes it to reflect across the y-axis. And finally, let's do the 1/2 and the 5x. Pull those up and we'll do them. Let me keep the square root of x. Let me delete that and keep the square root of x first. Then let's insert 5. Okay, whoops. Let's delete one of those. Well, I didn't want to do that. I want to delete this, and let me insert my parenthesis, and I lost my radical. There we go. And I think the other one was what? A 1/2. So here, let's type in parentheses 1/2. So let's graph the regular square root function, 5 times the square root, and 1/2 times the square root of x. Let's see all three of them. So there's basic square root. There's 5 times the square root. And there's 1/2 times the square root. Notice they're all arcing out to the right. The 5 caused it to stretch up. The 1/2 caused it to shrink down. Those are called vertical stretches and shrinks. So here we see a vertical shrink and a vertical stretch.